Hi everyone, welcome back to another video. In this video, we will going to talking about what is moving average model and how to find order of the model and also how they used in the time series forecasting. I am going to give a real life example to make this video seem very good. Before that, let know the formal definition. What are moving average models? So, moving average model is basically a model that predicts future values of a time series using the past errors. That errors are made at the last time period of prediction. Here we defining the model yt equal to nu plus theta into zt minus 1 plus zt for t equal to 0 plus or minus 1 plus or minus 2 etc., where zt is the error making the current time prediction, which is follows white noise model with mean 0 and variance sigma square, and theta is a real valued scalar constant lies between the value minus 1 to plus 1. So this how equation looks like. Since we are uses the error in the prediction time period to make a prediction, it's called a moving average model 1. It may confuses you. Why errors used to predict the future value? Let explain by real life example. Let example for moving average model 1. Let's see this graph of the actual cab required by Uber during the coronavirus pandemic, and you have to make your prediction. Say you are a data scientist and we have to make a prediction about number of cabs that are going to required in the next day. So let's start with the day 1. The dark blue line is the actual cabs and the light curve line is predicted cab. At the first day actual value is 80. Probably this in 1000, say 80,000. So there is no prediction value and error. Next day you are asked to make a prediction, but now you do not have any idea of the time series looks like. So assume that it going to be same value. Let make a prediction 80 and let's see the actual value jumped to 140 cabs. So you made an error in prediction. The error is 60. So in time series equation, let's see you are taking a constant theta equal to minus 0.5 and mean mu equal to 80. So initial mean value nu equal to 80. So now you see that you make an error. Right, you can see that this graph is moving average graph because the average is increasing, averages are not same, right? So you're not gonna be right enough to make same prediction for the next period, right? Now they ask you to make a prediction, not take 80, take the average you made at last time period, this minus 60, and multiply by constant theta, which is minus 0.5, we get 30, and you adding 80 to that you get 1110, which is next prediction you going to make, right? So since the actual value is increasing, the cost of taking the error in last time period, you are unable to keep up with the trend. That why use errors, right? Because in moving average graph the averages constantly going to fluctuate. Since you have to check the error you made and make a revised prediction. Because of that, let's see the actual value at third day increased to 20 and equal to 160, right? And the error you made was minus 50. So you again take the mean, take the error, multiply by 0.5 to get the prediction value as 135. which is same as the predicted value, and error is 0. You predicted the correct prediction at the 4th day. So, and proceeding the graph like trending and look like this. The whole point is very simple. Because of the mean, because the average of a moving average curve graph is gonna constantly change, you need to keep noticing the error in the previous time period to make a better prediction. That gonna helps you to keep up on a trend. You can see in this graph, as actual cap increases, the predicted cap is also keep up with a similar trend. To get the exact same value, you might have to change the value of constant theta at the first time itself. Let's say increase it by 0.9 something, but taking the errors helping you keeping up the trend. That's why use this model for moving average. Now in this case, use the average of previous time period, right? So to make a correct prediction, you can also use the errors made in 2 times period back or 3 times period back as well. Different types of moving average models. Moving average models of order Q. Let's look at the different moving average models looks like. Moving average model of order 2, which is yt equal to mu plus theta 1 into z t minus 1 plus theta 2 into z t minus 1. Moving average model 2 look like this, where we simply add the error of 2 period back as well, multiply by some constant to make a prediction. In moving average model of order Q, you take to account the error up to Q times period back. Let's see example in R programming. Here we are going to make an use of the inbuilt data set air passenger monthly totals of international airline passenger from 1949 to 1960. The data of the structure is seen, 112, 113 number of passenger. Okay, let that defined by yt. Then moving average equal to we define the moving average, use this inbuilt function stats filter of x comma replicate 1 by n comma n times sides equal to 2, get the moving average. And defining moving average 1 equal to a value of moving average, already define the function at the replace by yt. Moving average we got is 5 years moving averages there. Let plot the graph of actual value with the moving average values. Let's plot from on x-axis 1 to length of yt, on y-axis observations yt, and type is line, and y-axis limit is minimum to maximum of yt values, and say x-axis name time series and y-axis title values. Then the graph looks like this. This is the actual values graph, where the x-axis time series and the y-axis the values of the time. Therefore, by taking a line of moving average, we get, and the legend to represent, we finally going to get an graph of, here the dark line is time series of actual value and the red line is the predicted moving average values. And now how do we figure out which model is used? For that we use the function called autocorrelation function. Let now the basic idea about autocorrelation function. ACF is measures the correlation between current time period and previous time lags, right? It will gives you an idea of whether the value today is really dependent on my value at 2 or 3 time periods back, right? So takes into account the direct and indirect effect by use ACF in this case. Value is going to be between -1 to +1 for Pearson correlation coefficient. +1 means the positive correlation and -1 means negative correlation. Meaning one variable increases and other decreases. So when you plot a ACF plot, the graph is like this. Basically on the x-axis you have the lag time period, along the y-axis you have the correlation. So you can see that t-1 period, which is the first value on the x-axis, as a correlation of 0.5 or 0.44, which is a good correlation, and for the rest of the time period correlation is very low. This blue colored dotted lines called the error band, and if the correlation lies between these is not statistically significant. So in this case, if you get a plot like this, you would use moving average of order 1. Based on the ACF plot, we can get a different type of time series models and use that for the time series forecasting. Similarly, the moving average of order 2 looks like this. 2 of the time lag period crosses the error band, that is lag time t-1 nearer to 0.6, and at lag t-2 the crosses the error band, so that this can be used for moving average model 2. Now we can see how to plot a ACF curve in R. The following data gives the data on a chemical process observation being taken at every 2 hours interval of time. Say YT are the observation taken on the chemical process. Let define T is the lag times, say from 1 to 50. Here we have the 50 observation, therefore define Y. The inbuilt command for plotting the autocorrelation function graph, we going to use the inbuilt command called CF of YTR observation recorded. Therefore the graphs looks like this. We are clearly see only one vertical line